Hi, everybody. My name is Rishi. I'm a privacy engineer at Oasis Labs. So at Oasis, we're committed to building a responsible data economy. Part of that is ensuring privacy preserving data sharing. And so to that end, uh, I'm happy to introduce our product, Private SQL. It's exactly what it sounds like, being able to query SQL databases in a privacy preserving way. So with differential privacy, the way that it works is it essentially accepts incoming queries and rewrites them to be differentially private. So it includes the clipping and the noising operations within the query itself. It does this by breaking the query down to an abstract syntax tree, and then based on schema information that it has about the data, determining what the sensitivity is, and so what the clipping and noising operations need to look like. This also means that the data stays exactly where it is in SQL databases, whether that's on a public cloud or something on premise. And the actual query, the rewritten query, is executed within the database, and the answers streamed out of the database are already differentially private. So we support basically all standard SQL dialects, most extensively tested against Postgres, MySQL, Presto, Athena, etc., and a broad range of SQL queries. So the aggregations that we support are sum, count, average, standard deviation, variance, min, and max, as well as joins against private or public data, as well as like with clauses and arbitrary depth subqueries. We support different budgets as well. So this is pure and approximate differential privacy, as well as regular ZCDP and approximate ZCDP. And you can specify this based on different groups of users as well. So if you have different projects within your company or within your team, each project can get their own budget for differential privacy. And we have automatic enforcement both of differential privacy as well as any other rules you set up to govern how to access your tables. So if you have specific columns that you want to blacklist or columns that you want to be able to use but not expose, for example, as join keys, you can set those rules, and any queries that don't meet those rules will automatically be rejected and not hit the privacy budget as well. So we recently released just this summer on GCP Marketplace. So you can set up your private SQL instance and connect to either data that you have sitting on GCP or other public clouds through our GCP interface. And we have multiple interaction surfaces. So on the screen is our Python client, where you can easily run SQL queries. We also have a CLI as well as a no-code interface for any analysts that don't want or know how to write SQL, and that's based on Apache Superset. And finally, we have a portal for DP admins to be able to easily configure privacy parameters with some visualizations on what accuracy guarantees, as well as privacy risks look like for different values of these privacy parameters. The last thing is we are HIPAA certified under the expert determination clause by an expert actually in this room. And so if you have any private healthcare data, we don't require BAAs to work with us. You can just start using our product out of the box. Thank you.
Thank you. Liudas, you're up, and then on deck will be Sharat Chandra.
Hi, I'm Liudas Panavas. I work at Northeastern University, and I wanted to talk about a project that I'm working on this summer. So I'm working with the Urban Institute, and we're trying to release IRS data, which is super sensitive. And right now, there's only really like two ways to work with it, and that is either through public use files, which aren't super helpful, or going through a like really extensive vetting process to get access to the raw data. And kind of what we're hoping to do is find a middle ground, which is an interactive query system, which I guess similar to what we just saw. And one of the things that we ran into when we were thinking of how to make it is that a lot of assumptions are made about users' background knowledge and how they'll work with a system like this. So for instance, in most DP papers, there's an assumption that someone's going to be able to set epsilon. And from coming to DP, coming to this, I kind of figured no one really knows how to set epsilon well, and especially not someone who does like public policy research. I don't think in an hour they're going to be able to figure out differential privacy literature and figure out epsilon. But on the other hand, these statisticians, public policy researchers, they know how to set accuracy metrics of different kinds. Like they know how to set standard error, what standard error is going to work for them. So what we're proposing is if you have an interface to like remove any differential privacy knowledge from the users, so they don't have to ever set or interact with epsilon. But we would like them to still be able to set an accuracy metric. So especially if you're a public policy researcher, you do need data that's gonna be valid and fit in your hypothesis. So when we think about that, we found kind of like two questions that we don't have exact answers for. Talking to people over the last few days, I feel like some of the answers are swirling about. But the two questions are, which accuracy metrics can users set and understand, especially in relation to their downstream task? So obviously, when you test algorithms, there's a lot of different accuracy metrics that people use. But are those the accuracy metrics that will actually help users? So if you have a relative error of 10% or 15%, is that something a public policy researcher is going to know that I need 10% or 15%, or is there a different accuracy metric that might work better for them? So that's one question that we want answered. And then depending on what accuracy metric or what level they need to set it at, can we choose the privacy loss parameters privately and return the data? So that way they never have to like set an epsilon or never really have to interact with it. So yeah, if you're interested in either of those questions and want to apply your theory to a real world problem, you can reach out at my email and I'd love to talk about it. And yeah, put some of that theory into practice.
Got it.
Hello, hello. Do I stand in this spot? Okay. So we'll change slides at some point.
Oh, yeah.
Great. So I don't have any products, and I mostly just want to talk to you about what Ford or like how Ford uses privacy or why we need to use privacy. So a strange and kind of frequent point of conversation I get is what does Ford do with differential privacy? I get this question quite a lot. And unfortunately, the powers that be have stated that I'm not allowed to stand here and tell you exactly what I do. But what I will do instead is I will say that I'll give you some like evocative examples and motivation for like why we need to be doing this. So I often say that cars are like smartphones on wheels. In fact, cars are more than smartphones on wheels. They are the kind of bridge between our physical selves and our digital selves. In almost every meaningful event of our modern lives, our cars are usually there. Our cars know where we live, they know our work, where like which hospitals we frequent, which grocery stores we go to, our favorite restaurants, the places of worship we go to. It knows the routes we take, our trajectories, the temperatures we prefer, how loud we like our music, how warm we like our seats. The radio stations we listen to can help the car deduce our political leanings or what languages we understand. External video cameras will like locate, our immediate surroundings, and internal video cameras locate our face. Which highways do we tend to take, and are there ad campaigns in those highways that could more likely affect us than other people? Our behavior patterns, are we aggressive drivers? Are we safe drivers? And who's allowed to know that information? Is it governments? Is it insurance companies? These are all big, issues. And finally, you also have issues of fleet vehicles where things like police departments will often have contracts to buy vehicles from, one particular manufacturer. And so if data is being tracked, are we tracking police departments? Are we tracking their work vehicles and even their home vehicles? These are all like big issues of privacy that need to be dealt with. And of course, this is a compliance requirement for treating this data appropriately and building privacy into the systems of collection and retention that we have. But more broadly than that, Ford has repeatedly and consistently articulated that privacy is a priority for the company from the top down. And I kind of hope that in addition to being compliant, that privacy ends up being something that makes Ford, or that is a market differentiator for Ford. This is a little bit of a personal hope, but we hope that our team can grow this and make it like broader and broader priority over the years. We have a lot of work to do, of course. Our team is very young, but it's my hope that Ford can be known as a car company that explicitly and provably respects privacy of customers in the US, in North America broadly, in Europe, and anywhere else in the world that we sell our vehicles. And that possibly can give us market advantage over both like domestic and overseas competitors. And finally, as you'll hear from my teammate in a little bit, or in the next session rather, that even more than compliance requirements and the business value generated by privacy, consumers actually care about their privacy and how the vehicles handle them. And I think it's our duty, and both our duty to our customers and in the service of broader social good, to cultivate and preserve the trust of customers to the best of our abilities. So our team is really young, and we're building towards this vision. The community, and this community specifically of academics, and like the OpenDP conference, the TPDP conference, has been extremely valuable. I like last year when I was here, basically as soon as I got home, I like tried to implement some of the stuff that I saw that y'all were making. I know there's like definitely people in here whose work I have implemented directly in our systems. I have talked to some of you like via video chat and asked you questions. I bug people a lot. You've maybe seen me in the Slack. So I try to reach out to as many people as possible. I read your papers. I watch your lectures. All of this information is extremely important to us. So as our team matures, we expect to contribute to the community as well. My hope is that in the coming years, we will help. We will have our own poster sessions. We'll contribute to OpenDP and ask you questions and put in feature requests as well. And with that in mind, if I've caught your attention caught your attention and your interest, and you still have the question of what does Ford actually do with differential privacy, we have job openings. Please apply to them. We want you. You're great at this, and we want you to help build our systems up. Yes. So if that's pretty much it. Yep. If you're looking for industry jobs, and please apply. And I just want people to think more about connected vehicles as the domain and motivating example for future research. So thanks.
All right, Lipika, you're up.
I forgot what the title was and I can't see it, but that's okay because Christine set me up really nicely for this 5-ish minute summary of what we are doing at Gretel with privacy scoring. So ignore privacy scoring, just think like adversarial attacks. But the difference is that we work in sort of a no box threat model where an attacker really only has access to synthetic data and some portion of the training set, or they have some external information, right? And when I say curated synthetic data, I say that because that can be with differential privacy guarantees. It could be without, it could be from anywhere. Just think any data set, right? So kind of separated from the algorithm. But we need to think about empirical privacy metrics, right? It's what Christine set us up to think about in our work as we're developing algorithms and as we're implementing them. So a couple of things that we've done at Gretel. One is implement a membership inference attack, and the other is an attribute inference attack. So in the membership inference attack, really very quickly, what we do is we sort of assume that the attacker has some subset of a real data set. And they go through and they also have some synthetic data that's been generated based on this real data or some subset of it. And what they do is they go through sort of line by line on the data set that they have, and they compare that to the synthetic data set. So you take each record, you normalize it, one hot encode, normalize the numeric variables. I'm ignoring text here, just caveat. And so measure the L2 distance between those and set some threshold. And if it's less than a certain threshold, then okay, great, membership is inferred. If it's not in the training set. So the attacker is able to understand or make some sort of prediction on whether the training example or the example that they have was actually a training example. So you can do this record by record. And as you can imagine, then you know the attacker knows something and that's their prediction. And there's a true set, and you can compute accuracy, precision, any number of metrics. And so what we do with that is we take that and we adjust the threshold. So we select several different thresholds. We also select several different attack sets, and we run through 360 simulations. And you can increase the number. I mean, all of this is configurable. And at the end of it, you get some indication of success of this attack, right? Like how many times is it successful? How many times does it fail? And we do some sort of scoring into different categories, and it looks like this nice pie chart, but I won't go into that. The other one is an attribute inference attack. And there, what's interesting is typically when you think attribute inference, an attacker has access to some quasi-identifiers, right? So there's, age, date of birth, something, and then you can re-identify the population. Sure. That's great, but in practice, it is really hard for a user of a synthetic data platform or a synthetic data algorithm to be like, okay, here are the 3 quasi-identifiers that I anticipate an attacker to have. So you sort of have to randomly select and simulate every possible combination of quasi-identifiers. Maybe it's sets of 3, sets of 4, or multiple sets of different sizes. And so roughly what we do in an attribute inference attack is, it's quite simple, but it's effective. We take a lot of different samples of attributes, and we use that to basically find nearest neighbors in the synthetic data set. And we find the 5 nearest neighbors. We do some sort of averaging of whatever the target is that we're trying to identify. So like, does a person have a certain medical diagnosis or not? Maybe that's what the attacker was trying to find out. And we use that to, we do that multiple times with different sets. And ultimately, we also weight we get some accuracy, right? Again, the attacker has guessed 1s or 0s, and then we have the true values, and we calculate accuracy, precision, choose your favorite metric. And again, we weight that by entropy. So for example, it could be that everybody in the data set is a female because we're talking about breast cancer. So there's like no entropy in that, but there's not really much that an attacker has learned. So we do some entropy weighting and again, classify into these categories based on where you fall in the accuracy bounds. So we've done a little bit of privacy scoring. We have privacy scores out there. It's highly configurable, but it's a tool for users of synthetic data generation algorithms to determine empirical risk. And it's really quite useful if you're using differential privacy in your algorithms, if you're not using differential privacy in your algorithms, but it's out there. Please take a look. Thank you.
All right, hi everyone. I will be quick to not keep people away from lunch. I'm giving this mainly on behalf of Marco Gaboardi, who wasn't able to attend in person. So many of you may remember that one of the motivations for having a community project to build differential privacy software is that implementing differential privacy correctly in a way that's faithful to its promises is very difficult. And most kind of attempts, even by experts, often lead to implementations that do not satisfy the requisite privacy guarantees, in part because of kind of numerical issues, not being careful enough about notions of adjacency. There's just many things that can go wrong. And so the vision with OpenDP is that all of the components, the main components, transformations and measurements and combinators that have the constructors for them in the library should have proofs attached to them. Mathematical proofs that the implementation satisfies the specification in the OpenDP framework, as Mike was talking about. And so That discipline has been paying off, of the discipline of having the precise specifications in the library that coming from the OpenDP programming framework that Mike was talking about metrics and domains and privacy maps, and several of the studies that have come out auditing differential privacy libraries. OpenDP has done quite well in not finding violations of the promised privacy guarantees, of avoiding users inadvertently violating privacy. But we have not yet realized the full vision of really having the community vetting process of library components. And now we are getting to the point where we're really ready to push that forward. We now have in place a OpenDP privacy proof review board that will be is chaired by Marco, and Michael Hay and I are we're using language kind of corresponding to like editorial boards of journals in research. Michael and Hay and I will be executive editors, and listed here is a great collection of volunteers from the community who have agreed to serve on the board and bring many different kinds of expertise, both in code and in mathematics of differential privacy. And we're going to get to work on starting to review the proofs that exist for library components. There's been many proofs that have been written. But as Mike said, we also have a number of components that still need proofs. And so call to the community to contribute more proofs, because now we have a board that can review those proofs. And over time, we will need more people to serve on the board. And so if you're interested, also please let us know. You can find more information about the proof review board, the process for submitting a proof, and what the format for a proof should be, and all of that at the link that's shown here.